Welcome everyone. In this lecture, we're going to have a quick crash course in NumPy arrays. When we actually read in image data, the computer is going to read it in as an array. In the next lecture, we'll describe that relationship between images and arrays in further detail. For right now, let's go ahead and focus on just pure NumPy, how to create arrays, and a few operations indexing and slicing on arrays. I'm going to head over to Jupyter Lab now. Okay, here I am at Jupyter Lab. I'm going to go ahead and open a launcher, so that's the plus button in case you don't have it yet, and then click on Notebook here. And now I have my Jupyter Notebook. Let me collapse that file, and I can also close the launcher. So the first thing we need to do is actually import NumPy. And the way we do this is we say import NumPy as NP. And I'm going to zoom in just a little more so you get a nice clear view of that. Okay, NumPy has already been installed as part of your environment, so you should already have it. There's a couple of ways we can create arrays. Most often, we'll just be reading images, and that will automatically create the array for us. But in case you're interested for a couple of other ways, if you have a normal Python list, such as my list is equal to 1, 2, 3, if you wanted to, check the type of my list here. It'll report back that it's a list. But what we could do is cast it as an array by saying np.array and then passing in my list here. And you'll notice if I just have it be returned, it returns back an array object. So then I could say something like my array is equal to np.array, and then I have my array here. And I can also check the type of my array, and it will report back, yes, in fact, this is no longer just a normal Python list, it's actually a NumPy array. So what's nice about these NumPy arrays is they're going to be able to take in different dimensions, so I can have a two-dimensional array. So let's show you a couple of ways to create arrays that are more than just a single list being casted to an array. One method I could use is the arrange method. And np-arrange, what it does is if you do Shift-Tab here, it'll give you the documentation string. Basically, it returns evenly spaced values within a given interval. So you give it a start and a stop and an optional step size. So here I could say start at 0 and then go up to, but not including 10, so 10 is the stopping point, and then give it a step size. Well, we'll go ahead and say 0 through 10 first. So here's my array, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Essentially, this is the range version in NumPy. So as you may know, Python has a built-in range function. Arrange is NumPy's version of that. So it goes up to, but not including 10, so 10 was its stopping point. As a third argument, you can pass in a step size. So by default, it's just taking a step size of one integer or +1 at a time. If we say 2 here, then it'll take a step size of 2. So it'll go 0 to 2 to 4 to 6 to 8 and so on. Okay, now often what we're going to be doing is creating a two-dimensional or three-dimensional array, all of one single value. So np.zeros is a useful function we're going to be using quite often. np-zeros, the main argument you do is just the shape. So what shape do you want this array? And what we're going to do here is say shape is equal to, and then you pass in a tuple. So I'm going to say I want a 5 by 5 array. And here we have 5 rows by 5 columns. So just to make that clearer, I'm going to say give me a 10 by 5 array. And you notice now I have 10 rows. So this first dimension, the index position here at 0, that's going to be the actual number of rows, and then the number of columns is the second one. So here we have 5 columns. Now you'll notice each of these zeros has a little decimal point after it. That's because by default, NumPy is going to automatically create floats instead of just pure integers. So arrange created integers, np-zeros is going to create floats. So it's 0 point instead of just 0. So if we check the type of 0 by itself, that's an integer. If you check the type of 0.0, that's a float. And then if you just check the type of 0 point, that's also a float. So keep that in mind. These are all floating point numbers. So zeros is something we're going to be using often throughout the course. The other one we're going to be using often is np-ones. And it's going to be the same thing. It takes in a shape argument. So you say shape is equal to, and you can say 2 by 4 or whatever shape you desire. And then we see 1 point for 2 rows by these 4 columns. Keep in mind, you don't have to declare the shape parameter. Often you'll just see it done like this, and that's the same thing. All right, so that concludes talking about how to create arrays from scratch. The main ones we really need to know here that we're going to see all the time throughout the course is np.zeros, which creates an array of zeros for us, and np.ones, which creates an array of ones for us, where this first value in the shape is how many rows you have, or the height of the array, and the second one is how many columns you have, or the width of the array. So a little bit counterintuitive as far as relating the first one, number of rows to height, and the second one, number of columns to width, but that's going to make a lot more sense when we start reading in images. Okay, now let's go over a couple of operations. I'm going to do Shift-Enter a couple times here to get some new cells to kind of clear some of that old stuff out of the way. So now what we're going to do is we're going to start off by setting what's known as a seed. So we're going to say np random seed, and then pass in 101. What this does is it allows me to create the same random numbers each time. So I'm doing this because I want to have some random numbers for this next series of operations. So if I wanted to create random data, I just need to say np.random.rand, int. And if you do Shift-Tab here, basically this describes this particular function. It's just going to create and return random integers from low inclusively to high exclusively. So that means I'm going to say here, grab me from 0 to 100, give me 10 random numbers. Notice how my seed and the creation of this array are actually happening in the same cell. The reason I have 101 here is just a seed number. The actual value is pretty arbitrary, but I want you to use the same number I do. That way when you actually create these random values, you get the same random numbers I do. And you can do a Google search on things like random generation or random number generation to actually figure out the complex mathematics behind these seeds. But for our purposes, that's kind of irrelevant to the course. I just want to make sure you get the same random numbers I do. So if you run this in the same cell, when you get that array, you should now get the same values here, 95, 11, 81. And what we're going to do is immediately after that, create one more array. So we'll say np random rand int, and say grabbing numbers from 0 to 100, give me 10 more numbers. And then when you check out that second array value, you should get the same values I do. If you do not get the same values I do, go ahead and just rerun these cells again in the same order. Okay, so now what we're going to do is show you a couple of operations that are useful, such as finding the max and min and mean of an array. So if you ever want to find out the max value of an array, you can say arr.max, and this returns back the actual max value. So notice here the max value is 95. If I wanted to figure out the location of that max value, I simply need to say argmax, and it will return back the index location of that value. So at index 0, just like a Python list, you'll notice here that we have 95. Okay, so we can do the same thing for min. So I can figure out the minimum value by saying r.min. So the lowest or minimum value in this array was 9. And if I wanted to figure out its location, then I just say argmin, and it's at index location 7. So if I count over starting at 0, 0, 1, 2, 3, 4, 5, 6, and then at 7, we have the minimum value of 9. Okay, and finally, if you want to figure out the average value or the mean, you can just call rmean. And there we have the average was 60.8, so it calculates the mean. Something else you can do is you can reshape arrays. This is sometimes useful. So if I check out the shape parameter, notice how I'm just calling shape with no parentheses here. It returns back a shape, 10, comma, and then nothing, because it's actually just a single vector. What I could do is say reshape this to another set of dimensions. So if I do Shift-Tab here, it'll say, okay, what shape do you want it in now? Well, let's imagine that I wanted to reshape it to be 2 by 5. So now it's reshaped this to be 2 rows by 5 columns. If I try to choose values that don't make sense, such as 2 by 10, it's going to give you an error. It's going to say, hey, I can't reshape an array size 10 into shape 2 by 10, which makes sense because if you have an array of 2 by 10, that means there's 2 times 10 elements. That means 20 elements. However, you only had 10 elements to work with. So that's why it's giving us an error here, because those dimensions don't make sense. But we could always reshape to something that does make sense. It's like 5 by 2. Since 5 times 2 is 10, and we have 10 elements, that works out just fine. Okay, so that's the basics of operations that we need to know. Lastly, we want to understand indexing. So I'm going to make a couple more cells here to clear out some of the space. And I'm going to create a variable called mat for matrix. We'll say np.arrange 0 to 100, And then immediately after this, instead of doing this in 2 steps, I'm going to do it all in 1 step. I'm going to reshape this to 10 by 10. And now if I check out my mat, I have this array of all the numbers from 0 stopped until 100 or 99. And then if I want to check the shape of this, it's 10 by 10. So let's imagine that I wanted to grab a single digit from this array. What I do is I use indexing. So let's say I want the value at row at index 0, where column is index 1. So what value is that? Well, row 0 is this first row. Column 1 is the second column, because if we start counting at index 0, 1, so that's going to hopefully return back 1. And the notation for this, or syntax for this, is MAT, or whatever your matrix or array happens to be called, and then you pass in the row, comma, the column. Run that, and we get back that value of 1. I would encourage you now to pause the video and try to choose a number somewhere in this matrix, and then see if you can index out that number. So for example, see if you can grab just the number 46 from this matrix based off the logic we just showed you here. Okay, so let's quickly show you how to do that. So if I wanted 46, then that's at 0, 1, 2, 3, 4. So that's row number 4, and it's at column 6. So here we just actually wrote out row and column, but you can pass in the numbers directly. And there's 46. So that's also kind of the reason we chose these particular values from 0 to 99, because you can really quite clearly see the index locations. Notice how the first number here is representative of the index of that actual row, and the number here is representative of the index of that column. So 46 was actually quite easy. It was 4, 6. Now let's imagine you wanted to grab all the items in a row, or all the items in a column. You do that with slicing. So we say mat, and then we're going to say colon, and then pass in some column value. Let's go ahead and pass in column 1. So what that returns back is every single value for every single row in the column 1. So if I take a look at my matrix again, notice here that my matrix has this column 1, 11, 21. So that's the column I asked for. And with the colon, you ask for everything. So in this dimension, those were the rows. So I asked for the value of every single row just for that particular column. So it's essentially just asking for that entire column back. You'll notice here that the shape returned is 10, nothing. If you actually wanted to get it in this shape, then you would have to say mat colon, 1, and then reshape to the particular shape you wanted. So if you wanted it to be 1 row by 10 columns, you could get something like this, or you could reverse it to have it this other way. That looks more like the original. Keep in mind, depending on what IDE you're running, you may not actually see this output formatted the same way, but hopefully you kind of get the idea here of the different shapes something can be returned in. Okay, so that returns back an entire column. If you want it back an entire row, it's essentially the opposite. You ask for every column for a particular row. So let's get a row here. Let's just row 2. And then we'll say colon, give me everything there. And now we get back everything in that row. So notice when I ask for the array, I'm basically saying, okay, go 0, 1, 2, and then give me every single column for this row, which is just that row itself, 20, 21, 22, and so on. Finally, often you can actually grab just mere chunks of this. So the way we do that is through slicing. And then we use slice notation just like you do for a normal Python list. So let's imagine I wanted to grab this first 3 by 3 here. What I could do is say starting at index 0, colon 3 for those rows, and then for the columns, do the same thing, 0, colon 3. And what that does is it says, okay, grab all the rows starting at 0 up to, not including 3. So here are all the rows, 0, 1, and 2. And then grab all those columns, 0, and then 1, and then 2. So we can expand this to get a better idea. So if I kept going with those particular columns, it'd start giving me more of those rows. So give me the additional column there, 0, 1, 2, and 3. Essentially, this is just normal Python slicing notation, just the same way you would slice a normal Python string or a normal Python list, but now it's happening along 2 dimensions. Don't worry too much if this notation is a little confusing to you. We actually won't really see it that often throughout the course. Usually what we end up doing is we just take a quick slice of maybe everything, and then reassign it. So the last thing I want to show you is if you wanted to actually reassign these numbers to a different value, you could say equals 0. And then if we check out the matrix again, the original matrix has now been affected, and now that entire chunk is equal to 0. If you want to actually affect a kind of copy of the matrix, what you could do is say my new mat, or whatever you happen to call this variable, and then say mat, and then call copy. And that's a command we'll see throughout the course. So sometimes you want to make a copy and then maybe set all the values to something else. So if I wanted to reset all the values, so if I look at my new mat right here, is a copy of that matrix that's already been affected. Let's actually just turn everything on this top half into zeros. So how do I do that? Well, I want to grab everything from, let's say, 0 up to, but not including 6. So I want to grab all those rows, and then I want to grab all the columns. So I'm actually just going to grab everything there. And let's set those all to 0. In fact, let's set them all to 99, just so it's really obvious. We'll do 999. There we go. And if I check out my new mat, now we go ahead and set kind of that first top half into 999. Okay, again, really just doing normal Python slicing notation that you've seen before if you're already experienced with Python lists and strings, just doing it along 2 dimensions. And as I mentioned, we really don't do this that often throughout the course. It's just a few times we want to reassign some image pixels. Okay, so that's the basics of NumPy. Coming up next, we're going to learn about NumPy. Well, we'll actually learn first what an image actually is in reference to a computer, and then we'll learn how to directly work with NumPy and images. Thanks, and I'll see you there.